Hello Lightning Leaders, and welcome back to another math video. I miss all of you. I'm really enjoying reading your comments on my other videos, hearing from you and your parents. Thank you for keeping up on your work. I miss doing this in person with you. I can't wait to do that again soon. Little funny story for you. I actually already recorded these videos for the fractions that we're about to talk about. Went to go take it from my iPad and put it on my computer, and it was shot all in slow motion. So I had to delete them, and now we're doing them again. So hopefully these turn out just as good as the last ones, because I was pretty happy with the last ones. Pretty mad at myself right now. But wouldn't be a math lesson without Mr. S making a mistake of some kind. So here we go again. Today we're going to talk about fractions. And fractions they're not easy. They're not easy. We've been working with fractions since 3rd grade. This year in 4th grade, we raised the bar a little bit. But right now, we're going to backtrack and really just talk about what a fraction is. And before I do that, I want to talk about the number 12. And I chose the number 12 as just a random number. It has nothing, the number 12 is nothing specific to what we're talking about today. But the structure of the number 12 is what I want to discuss. There's 2 digits in the number 12. The digit 1 in the tens place, and the digit 2 in the ones place. We recognize this as a number. You know number 12, you've seen it a million different times. You know that these 2 digits together make up one number. The same goes for a fraction. Believe it or not, that is a number. It's a number with 2 digits. And just like up here, the 1 represents something and the 2 represents something, we know that the 2 is 2 ones and the 1 is 110 based on their place value. The same goes for the fraction. The 1 in the top represents something. The 2 on the bottom represents something. But the thing that they represent is what's hard about fractions. Because where we're looking, if we were actually to think about a number line, where we're talking about, especially if the number on the top is smaller than the number on the bottom, we're talking about between 0 and 1. And up to this point, when you were taught to count, you went 0, 1, 2, you didn't even think about anything else. You just kept going. Well, we're talking about numbers that are in between 0 and 1. And there's actually an infinite number, a never-ending number of fractions, of numbers between 0 and 1. 1/2 is one of them, just happens to be smack dab in the middle. Now we're going to talk a little bit more about what these parts mean. I told you that the top part was called the numerator, and Apollonia, if you're watching this, you will definitely fix my spelling if I spelled it wrong. Numerator. And our bottom number is the denominator. Denominator. Okay. Now, each of these means something. I told you that a fraction, especially when the number on top is smaller than the number on the bottom, we're between 0 and 1. So what we're looking at is we're pretending we took something, anything, any complete thing, and we broke it up into pieces. But we didn't break it up into random pieces. We broke it up into equal pieces. Each piece is the same size. And the bottom number tells us how many pieces of that one thing were created. The top number tells us how many of those pieces we have. So for example, the fraction 1/2, I started with a complete thing, broke it into 2 things, and I only have one of those things. Now I know some of you just got lost as I was explaining that. And that's the tricky part about fractions. Unlike at the number 12, where I can just say, yeah, this is the ones place and that's the tens place, it doesn't work as nice with fractions. But you have to understand that this number is not separate from this number. They go together. When you see a fraction, the top and bottom number go together. This whole thing is a number. And that's something you have to remember when you're working with fractions. We're not going to be doing something where we interact with the top and bottom number. They're always going to move together. Let's move on to the next part. and that's equal fractions. You're going to find that on page 24. Today we're going to be doing pages 24 and 25 of your packet. And to expand upon what I was talking about a little bit there, about understanding exactly what a fraction is, I'm going to talk about question 1 on page 24. And question 1 on page 24 has 2/4 times, then it has an empty spot here, and it says it equals 8/16. We have to find an equivalent fraction. Equivalent. It has the equal in the beginning of it. We have to find a fraction that represents the same amount of space from 0 to wherever we're stopping. Now, 2/4 is the fraction we're starting with, and we have to get to 8/16 somehow. Now, there's a special rule that comes to making equal fractions, and it's this. Whatever you do to one digit, you have to do to the other digit. You can't do separate things. Like I said earlier, these go together. This is one number with 2 digits in it. And whatever I do to one digit, I have to do to the other digit. I need to think, what is going to get me from 2 to 8? What times 2 is 8? Well, I can do my skip counts to figure that out if I don't know my math facts. 2, 4, 6, 8. Oh, it took 4 fingers. 2 times 4 is 8. Now let's check and see if 4 times 4 is 16, because our rule is whatever we do to one digit, we have to do to the other digit. Whatever I do to the top, I have to do to the bottom. So let's see. Let's count by 4s 4 times and see if we end up at 16. 4, 8, 12, 16. It worked out. So now we know that if we take 2/4, we multiply it by 4, we're going to get an equivalent fraction of 8/16. And that was question 1 on page 24. Now I want to jump down to question 6, because this time there's 3 missing numbers in the question. And let's see if we can figure this out. It says 5 sixths times something equals something over 12. Now, to recap what we've talked about so far, this is telling me that one complete thing was broken into 6 equal pieces, and I have 5 of them. We don't need to worry about where the missing one is. It's just somewhere else. We have 5 of the 6 things. I'm multiplying it by something to make it into 12ths. Well, let's think here. I know my rule is whatever I do to one digit, I have to do to the other. And I can't figure out, I can guess a million things with my top digit, but there's nothing here. So let's start with my bottom digit, my denominator. And let's see if we can figure out what number is going to fill in this blank. I have a 6, I'm ending at 12, and I'm multiplying by something. So in my brain, I'm going, okay, 6 times something equals 12. I'm going to skip count by 6s until I get to 12. 6, 12. Oh, 2. 6 times 2 is 12. Now my rule again, what I do to one digit, I have to do to the other. So 5 times 2, 5, 10. Now I know that 5 sixths times 2 equals 10 twelfths. As always, the answers are going to be put at the end of this video. And I want to talk about question 10, because question 10 says, explain the strategy you used to solve the problems and explain why. Well, we used multiplication. Why? Because we could use multiplication to figure out our equivalent fractions. We used our strategy of using our multiplication facts to figure out what our equivalent fractions were. And that's what they're asking for in question 10. Now, when we move to page 25, we're going to take what we learned here, what we used here, plus a couple other strategies that you may or may not like. You get to choose, because it doesn't tell you to use a specific strategy, which I like those pages the best. And we're going to talk about a few different strategies we can use to now compare the fractions, which means we have to decide which one is the bigger fraction or if they're equal. So let's give this a try. On page 25, I'm going to start with question 1. And I picked question 1 because there's actually a nice little trick here. And those of you with math brains probably picked up on it right away. Now, there's something we have to talk about with our bottom digits now that we're comparing our fractions. There's a little saying that I have, and it's not mine, I didn't invent it, I stole it from a 4th grade teacher over at Lindbergh, Mr. LaRussa. And he says that the bigger the number, the smaller the piece. The bigger the number, the smaller the piece. And what that means is, the bigger the digit in the denominator, the bigger the digit on the bottom of our fraction, the smaller those pieces are. Because if we were to look at this in a picture, we would need 2 rectangles that are the same size because we're comparing these fractions, which means we had to start with a complete thing that is the same size. 2 things that are the same size. But what I'm doing is I'm saying maybe I'm breaking up the black marker into 4ths and the blue marker into 8ths and taking 3 pieces from each of those, and I want to see which one I have more of. Well, if I were to draw this out, if I were to make 4ths, I can make halves and then split them in half, and now I have 4ths. If I were to make 8ths, I need my 4ths, and then I just split them in half again, and now I have 8ths. And I just have to color in 3 of them. Oh. Now I can clearly see that 3/4 is way bigger than 3/8. I could have solved this without even this picture, because I can just tell myself, wait, the bigger the number, the smaller the piece, which means 8ths are smaller than 4ths. And if I have 3 of these and 3 of these, and these are bigger, this has to be the bigger fraction. Another strategy we could have used to solve this is we could have thought about 1/2. 1/2 is what we call a benchmark fraction. When we were learning to multiply, we started with 2s, 5s, and 10s. Those are nice, friendly numbers because we can picture them easily. 1/2 of something is something that's nice and easy to picture right away in your brain. If I were to put 1/2 on this picture here, there it is. And I can think to myself, oh, 3/4 is more than 1/2. 3/8 is less than 1/2. Since this fraction is more than 1/2, this has to be the bigger fraction. Now we're going to take this 1/2 strategy and we're going to use it on a different question that may look scary at first, but it's really not as scary as you think. I'm jumping down to question 8 on the page. And question 8 looks a little something like this. 53 over 100 compared to 1/2. Whoa. All right. Don't let the big numbers scare you. This isn't as bad as you think. We just have to slow down, hit the brakes, and think. We can figure this out by actually not doing any math. But I'm going to put some math on here so you can see my thinking. Like when I always ask you to show your work, and you tell me you don't know how to, this is what I mean. I know what 1/2 of 100 is. We learned it in the rounding unit. When we were making our number lines and we had to find the halfway point between 0 and a number, right? Halfway between 0 and 100 is 50. 1/2 is 1/2 of something. If 50 is 1/2 of 100, that must mean that 50 over 100 is the same as 1/2. 1 is 1/2 of 2. 50 is 1/2 of 100. Now that I know that 50 over 100 is 1/2, all I have to look at is my top numbers here. Well, 53 of something is more than 50 of something. That's a lot better than trying to figure out what times 2 equals 50, but some of us have a hard time doing that. And we'd have to sit there and go 2, 4, 6, 8, 10, 12, all the way up until we hit 100, and we wrote it on our fingers. We would need 50 fingers. It's a lot of fingers. So by asking ourselves, well, what would 1/2 be? What is half of 100? Using that 1/2 benchmark to think to ourselves, oh, well, 53 is more than the half, which means 53 has to be bigger than 50. We're going to do one more together, and that one is question 12. And I picked question 12 because question 12 comes up again in question 16. So we're going to do them both together. And I like question 12 because now they're making it difficult. 1/3, 5/12. If we look at this question and we start going down the list of things we've tried before, we can't compare this to 1/2. And here's why. Going back to what I said before, the bigger the number, the smaller the piece. 3 is a bigger number than 2. Which means that the thirds, those pieces, if I were to split this into 3 pieces, the size of those pieces would be smaller than if I split this into 2 pieces. Which means that 1/3 is smaller than 1/2. And if I look over here, I know that 6 is half of 12. Well, 5 is less than 6, so I have less than 1/2 here. So both of these fractions are less than 1/2. So I can't use that to help me here. I think it's time to use some equivalent fractions. I can turn this 1/3, I can turn these thirds into 12ths by doing some multiplying. If I have my 1/3 and I multiply it by something, I'm going to be able to get 12ths. Just like that question we did on page 24, now I have to think to myself, something times 3 is going to equal 12. Well, let's skip count by 3's until we get to 12. 3, 6, 9, 12. 4 times. 3 times 4 equals 12. Our rule is, whatever you do to one digit, you have to do to the other. 1 times 4 is 4. So now I know that 4/12 is equal to 1/3. Those are equal. Now that I have the same number on the bottom, my pieces are the same size. I cut my one thing into 12 equal pieces. Well, now I have to ask myself, which one is more, 5 of them or 4 of them? 5 of them. 5 is more than 4. Now, question 16 says to check our answer using an area model. Now, this kind of combines a lot of things that we've learned, even all the way back to the beginning of 3rd grade. We've been using area models for a long time. They've just had some different names and designed a little differently. The word array might ring a bell in your brains. Rows and columns. Now I'm going to start by drawing my 1/3. Here it is. And now I want to create rows and columns to show 12ths. Well, I have 3 columns here. And I learned that 3 times 4 equals 12. So I need 4 rows of 3. 4 times 3 is 12. 4 rows of 3 is 12. So I need to break up this into 4 rows of 3. 1, 2, 3, 4 rows of 1, 2, 3. To show you that in an array here, this is what we just made out of our fraction. This is what we just made. 4 rows of 3. Now I can look and see, 1, 2, 3, 4 out of 12. There's my fraction. Now to compare it to 5/12, I can draw this same picture down here using the 12ths and color in 5 of them. Oh, well, look at that. It goes farther than this one. which means that this fraction is bigger than this fraction. And this is how we show it with an area model. As always, the answers to these questions will be posted at the end of the video. And if you have any questions on how to solve any of these, reach out to your teacher and they would be more than happy to set up a video chat with you and figure these out. I'm so happy you guys are continuing your work as mathematicians, and I'll see you next time. I believe my video is going to be adding fractions, because I think Mr. Horrigan's doing subtracting fractions. So I'll see you guys then. Bye.